Hi friends, today I am giving a lecture on phases of a compiler or a compiler phases. So it is one of the most important question in compiler design. The phases of a compiler can be divided into these phases. So first one is lexical analysis, second one is syntax analysis, third one is semantic analysis, fourth one is intermediate code generation, fifth one is code optimization, sixth one is code generator, and seventh one is symbol table management, and eighth one is error handler. Okay. So here the compiler can be operated in phases. So each and every phase has a particular function. So these two phases, that is symbol table manager and error handler. Okay, these two phases belongs to each and every phase. So here the lexical analysis phase can also contain the symbol table manager and error handler. Syntax analysis phase also contains symbol table manager and error handler. Semantic analysis phase also contains symbol table and error handler mechanism. Intermediate code generator also contains symbol table manager and error handler. Code optimization also contains symbol table manager and error handler. Code generator phase is also contains symbol table manager and error handler. Okay, so the input for all these phases is source program. Okay, first we have to given a source program to the compiler. Okay, after the source program is processed through all the phases of a compiler, then it can produce the target program. Okay. Next, first we have to go to phase. That phase is lexical analysis phase. So the lexical analysis phase is the first phase of the compiler. Lexical analysis phase is also called as scanning. In lexical analysis phase, okay, first we have to scan the entire source program character by character. Those characters are formed as a stream of characters that is called as lexemes. These lexemes are produced as tokens as output of the lexical analysis phase. Lexical analyzer can do lexical analysis phase. Okay, here we have to write lexical analyzer. Here the phase is lexical analysis. That lexical analysis phase can be done by the lexical analyzer. In the same way, syntax analysis phase can be done by the syntax analyzer. Semantic analysis phase can done by the semantic analyzer. Okay. Code optimization can done by code optimizer. Code generation can be done by code generator. Okay. So in the lexical the output of the lexical analysis phase is tokens. In the lexical analysis phase, the blank spaces between the characters can be eliminated during this phase. Okay. The input for the lexical analysis phase is source program. The output of the lexical analysis phase is stream of tokens. This is the description about the lexical analysis phase. That lexical analysis phase can done by lexical analyzer. The lexical analysis phase is also called as scanning. While reading the characters in the source program, if any blank spaces are there, that can be eliminated during this phase. Okay, while reading the characters of a source program, those characters that are read that can be formed as a stream of tokens. So that stream of tokens acts as the output of the lexical analyzer phase. Now consider the assignment statement. Position is equal to initial plus rate into 60. This would be grouped into the following tokens. So here position is one identifier, initial is another identifier, rate is another identifier. Okay, from these statement the identifiers are position, initial, rate. Next, equal to is the assignment symbol, plus is the addition symbol, star is the multiplication symbol. Here 60 is the number. Okay, so this statement can be formed as this one. Here when the lexical analyzer finds the identifiers position, initial, rate, that can be formed as tokens ID1, ID2, ID3. Here the token ID1 for position, the token ID2 for initial, the token ID3 for rate. Okay, so here after the lexical analysis phase, so this statement can be formed as ID1 is equal to ID2 plus ID3 into 60. Here ID1, ID2, ID3 are identifiers. So ID1 identifier refers to the position, ID2 identifier refers to the initial, the identifier ID3 refers to rate. Okay, now this statement after the lexical analysis phase can be formed as ID1 is equal to ID2 plus ID3 into 60. So this is the description about the lexical analysis phase. This is one example. Next, go for syntax analysis. Syntax analysis is the second phase of the compiler. Syntax analyzer can do syntax analysis. In syntax analysis phase, it groups the tokens of the source program and converted into some grammatical phrases. That grammatical phrases are used by the compiler to generate the output. This output can be represented by using parse tree. Okay, so this phase is also called as parsing. Syntax analysis phase can also be called as parsing. Here the input for the syntax analysis phase, whatever the tokens that are produced by the lexical analyzer phase, that are the input for the syntax analysis. What is the output of the syntax analysis? Parse tree is the output of the syntax analysis phase. Here the output of the syntax analysis phase is parse tree. The parsing can be done by parser. Here the parser converts the tokens produced by the lexical analysis phase into a tree-like representation called parse tree. Here, parse tree is the representation like a tree that is generated from the tokens produced by the lexical analysis. A parse tree describes the syntactic structure of the input. Whatever the input we have to given, for that input we have to represent the syntactic structure by using a tree called parse tree. Okay, suppose we can take the statement, so ID1 is equal to ID2 plus ID3 into 60. Okay, so this statement can be obtained from position is equal to initial plus rate into 60. Okay, so that can be represented by using a parse tree. So here assignment statement is equal to, okay, here identifier is position. Now this is the expression, this is the total expression for ID2 plus ID3 into 60. So this expression can be divided into expression plus this is also one expression. So this expression is identifier, identifier is initial. So here this expression is ID3 into 60. So this can be represented as expression into expression. This expression can be taken as identifier. Here the identifier is rate. Here this expression is number, that number is 60. Okay, this is the parse tree representation for the input string. Position is equal to initial plus rate into 60. Okay, so here the parse tree can also represented by using a tree called syntax tree. Here syntax tree is nothing but a compressed representation of parse tree. So in that one, the operator can be treated as interior nodes. Operands can be treated as children for the operator. Okay, operators can be taken as interior nodes. Operands can be treated as the children of the node operator. So for the same input string, position is equal to initial plus rate into 60. So the syntax tree is this one. So here the operators are equal to, plus and into. So equal to, plus and into are called as interior nodes. Interior nodes have some childrens. Interior nodes can be taken as parent nodes or root nodes. Okay. So here position is equal to initial plus rate into 60. Okay. This is the syntax tree for the input string. Position is equal to initial plus rate into 60. It is a compressed representation of the given parse tree. In this one, operators can be treated as interior nodes and operands can be treated as children for the node for the operator. Okay, so this is the syntax tree and this is the parse tree. Next phase is semantic analysis. So semantic analysis is the third phase of the compiler. Here the semantic analysis checks the source program for semantic errors. If any semantic errors are there in the source program, that are checked by the semantic analysis phase. Here it uses the syntax analysis phase. What are the operators and what are the operands are available in the expression and statement. So the main objective of semantic analysis phase is type checking. Okay, it checks each and every operator that has operands that are specified by the source language. Okay, it checks each and every operator that has operands. So that is called as type checking. That type checking can done by the semantic analysis. So for example, if a real number is used to specify an index of an array, for example, a of 1.5, okay, so this is an error. This error is semantic error. This semantic error is handled by the semantic analyzer in semantic analysis phase. Okay, it will be declared an error. That error is handled by the semantic analyzer at semantic analysis phase. So for example, it is assumed that all the identifiers of the statement position is equal to initial plus rate into 60. So this statement that are declared as an real, but 60 itself is an integer. All the identifiers here, position, initial, rate, are declared to be an real, but the integer 60 itself an integer. Okay, when here star is applied to be real, then the identifier rate and the integer 60 is also converted into real. This can be done while type checking is to be done. Okay, so during the type checking process, so then the identifier rate and integer 60 are converted into real when star is applied to be real. Okay, so here the integer 60 can be converted into real by using operator called int to real. So int to real, by using this operator, we are converting our integer into real number. Okay, so this tree is called as semantic analysis insert a conversion from integer to real. So up to this point, this is the same. This is the syntax analysis, but here the integer 60 can be converted into real by using a int to real operator. So here by using this operator int to real, the integer 60 can be converted into real, that is 60.0. 60 can be converted into real, that is 60.0. So this type of error is semantic analysis. This type of error can be checked in semantic analysis during type checking process. First of all, we are converting the identifiers into real, but the integer 60 is not converted. Now here the rate into 60. Suppose the star is applied to be an real, so the rate and integer 60 is also converted into real. But here 60 can be converted into real by using a operator called int to real. So by using this operator int to real, so it converts the given integer 60 into real number 60.0. Okay, this can be done during the type checking process at semantic analysis. The main function of semantic analysis is type checking. This can be done at semantic analysis phase. If any error is there, that error is called as semantic error. That semantic error can be handled during type checking process at semantic analysis phase.